Hello everyone, welcome to this session. So in this data assignment, we will be doing factor analysis and something that we have gone through in detail in the class. So what I'm going to do is I'm going to load the data first. I can just use this link to load the data. So the data is here. Now, so we do factor analysis mostly on survey data, on which we ask some questions from our respondents, and we ask them multiple questions, and those multiple questions can constitute unique variables. And factor analysis is a technique to find that. So let's suppose if we want to run a factor analysis on a set of questions we have asked respondents. So to run the factor analysis, the command is very simple. So you type in factor space in the items on which you want to run the factor. So let's suppose in this case, I will say item 13, 14, 15, 16, 17. So let's suppose these are the items I want to run the factor analysis on. And I run the factor analysis. So it gives me two pieces of output. So the first piece of output actually tells you which factors to retain. To know that which factors to retain, just straight away go to this eigenvalue here. If this eigenvalue of a factor is greater than 1, then you retain that factor. So which means here, STATA tried to give me 5 factors, but I will only retain one factor, which is factor 1, because the eigenvalue of this factor is greater than 1. And for our other factors, the eigenvalue is not greater than 1. So I'm able to make factors 2 and 5 irrelevant, and factor 1 is the only one that I retain. Now you go down to the next table. So in that table, you look at your retained factors, so which is factor 1 in our case here. You can have multiple retained factors. And from here, you will find out what items are relevant for those factors. And if you're doing an exploratory analysis, then the threshold for the items is 0.65. But if you're doing confirmatory analysis, which means you are just confirming what others have found, or you're using an established scale, then the cutoff is 0.8 for the item. So let's imagine we're doing exploratory analysis here. So if you're doing exploratory analysis, we will look at factor 1, and we will identify the items which load on factor 1, and we find that all the values are above 0.65. You can see that all the values are above 0.65. So that means all the items here actually load on factor 1. So then I can generate my factor 1 by using the generate command. I can say generate factor 1 is equal to, now since I'm using all of these items, item 13, 14, 15, 16, and 17, I will just take the average of these items. So I will type in this code, and I will just take the average of that. So there are 1, 2, 3, 4, 5 items. So I'll divide that by 5. So that gives me my factor 1 here. So what I've done in this process is I have done a factor analysis on these items, and I have established that all these items come together and they create a factor which is called factor 1. So that is how you do a factor. What I'll do is I'll just quickly do a factor analysis on some other items. So let's suppose I can do it from item 33 all the way till item 35. So I can do it on them. So when I run them, you can see none of the eigenvalues above greater than 1, so they don't actually constitute any factor. I can try some other items by adding other items to it. So I can add item 36, item 37. So once I do that, now you can see that it gives me one factor, which is factor 1, because the eigenvalue is greater than 1. And here, only item 36 is the one which is actually passing the threshold. So my factor 1 is just going to be item 36, right? So that's going to be my factor 1 here. So that will be the video, guys. Thank you very much, and there'll be a data assignment based on this.